Okay, the paper is 9702, October, November, paper 1, 2, and year 19, October number 19, paper 1, 2. This is physics 9702. And the question is, two cells with the electromotive forces E1 and E2 are connected with each other, and the internal resistances are R1 and R2. And the external resistances are the terminal potential difference across a cell 1 is 0. So this is cell 1. Which expression gave the resistance of the resistor R? Look, cells are connected in series, so we can apply Kirchhoff's second law. Suppose this is the direction of the current selected. Now, according to Kirchhoff's second law, the sum of EMF E1 plus E2, because both cells are delivering the potential in your selected direction towards the left, so both are taken positive according to this direction, is equal to the lost potential across each resistor, and it is equal to I R1 plus R2 and the capital R external resistance. So this is Kirchhoff's second law. So total potential supplied is exactly equal to the total potential used. So E1 plus E2 is equal to current I. This is series of single current I, internal resistance R1, internal resistance R2, and external R. But there is a statement that cell 1 has zero terminal potential, mean the whole of the EMF is lost across R1. That's why it is delivering zero potential to the outer circuit. So we can write EMF of the cell 1 is exactly equal to the potential lost across the internal resistance. So we can write I is equal to E1 over R1. Now substitute this I over here, then it is E1 plus E2, E1 over R1 for the current, R1 plus R2 internal resistance plus capital R external. Now it can be written as R1 over E1 times E1 plus E2 is equal to R1 plus R2 plus capital R. Now simplify this. So it is R1 E1 over E1 plus R1 E2 over E1 R1 plus R2 plus R. Now look, this is cancelled. So R1 left. So R1 also cancelled here, R1 and R1. So this side is R1 E2 over E1 and minus this R2 is equal to capital R because this R is required. So this R can be written as, take the LCM. LCM is E1 because this is R2 over 1. So it is R1 E2 minus E1 R2. So this is the expression for the resistance. So the correct option is A. So I repeat. So first we have to apply the Kirchhoff's second law. Sum of the EMF supplied E1 and E2 both are positive because this selected direction is anti-clockwise. So both cells are taken positive. I current and sum of the resistors R1, R2 internal resistors plus capital R external. But the statement is the terminal potential of this cell is 0, mean whole of the EMF is lost across the internal resistance. So E1 is equal to I R1, I is equal to E1 over R1. So this current is replaced with E1 over, this current is replaced with E1 over R1 here. So this is multiplied here, R1 over E1 times E1 plus E2. R1 plus R2R. When this bracket is open, R1, E1 over E1, E1 cancelled, R1 left, R1 cancelled with this right side R1. So left side now R1, E2 over E1, and minus this comes here with minus sign, minus R2 is equal to capital R. When the LCM is taken, the capital R is equal to small r1, capital E2, minus capital E1, small r2 divided by E1. So the option is A.